Welcome to the Mars Lab, coming to you live from our Mars Lab studios at the Powerhouse Museum in Sydney. I'm Craig.
I'm Isabel.
And boy, do we have a great guest for you today. Her name is Jennifer Shechet, and she's a planetary scientist with the Mars Curiosity mission. We'll meet her in just a moment. But first of all, let's meet all the other mission scientists from around the state who are joining us today. So let me see, PLC up there in Armidale. Can you give us a wave, please? Hello, hello. And what about Trundle Central? Over there in Trundle. Yes, hey. Everybody else wave to Trundle as well. Yep. And Casula High School. Yes, keep waving, Casula. Terrific, terrific to have you. And in our studio with us, we have some lovely lady students from Mary MacKillop here in Fairfield in Sydney.
Thanks for coming, ladies.
Yeah, thank you. All right, I said at the start that we had a fabulous guest, Jen Shechet, and she is. She's been a planetary scientist with the Mars Curiosity mission since it landed, and she's what's known as a keeper of the plan, which sounds very ominous, doesn't it? Yes, we'll find out what that means. And also, before that, she was actually involved in helping find the particular landing site for Curiosity. And she's also analysed the sedimentary rocks all around Mars with the HiRISE mission. That's the high-resolution imaging science experiment that goes on the Mars. It's the camera from the Mars Reconnaissance Orbiter. And it looks like we just have Condobolin. Is that correct? Condobolin logging in as well? Hello, give them a wave as well. So we have all 4 schools. So everybody, if you could all join in saying hello to Jen, we'll get started. So everyone, hello. Hello, Jen.
Hello.
Go.
So, Jen, thank you so much for joining us today. We really appreciate you taking the time to have a chat with us. We don't have a lot of time, and we have 4 schools joining us, and we have heaps of questions for you. So why don't we just get started right away? We have Jacqueline here who has a question for you.
Sounds good.
Craig said you are keeper of the plan. What does that mean?
So when we control the rover, we have 2 different theme groups. We have a geology group and an environment theme group. The environment theme group looks at the atmosphere and the weather on Mars, whereas the geology theme group looks at the rocks and, we study the sedimentology of Mars. So as a keeper of the plan, the acronym being a COP, we help create the fragments that get set up to the rover. So we will sit there every day and we will say, okay, today we have a 1-hour science block or a 2-hour science block, and we will decide what instruments we want to use, whether the cameras or the laser or our arm, and we will try and build a plan fragment that fits in the time allotted, as well as using the appropriate amount of power, and not to overuse some of the instruments, to get a good balance so that we get a good, well-rounded geologic analysis of all the rocks. So that's what we do as COPs.
Wow. Excellent. Safina at PLC Armidale, you had a question for Jen, didn't you?
What made you want to do your job?
So ever since I was 6 years old, I've loved outer space. And when I was 13 years old, I went to space camp in Florida, where you get to pretend to be an astronaut and be weightless and do all kinds of cool simulators. And I knew I loved outer space even as a kid. So I went to university in Earth and Planetary Science because I loved that you get to go all over the world and see different cool rocks. And so I happened to work for an advisor who was deputy project scientist for the Mars exploration rovers. And so he got me into Mars specifically, and I loved it immediately and ended up going to grad school for planetary geology, studying Mars, and I've been hooked on it ever since.
You've been hooked on Mars?
Yes.
What hooks you?
And I love outer space.
So what's the hook for Mars?
I love Mars because it's so explorable. We have these rovers there, and every day we get brand new data down. It's never boring. And while the other planets are great, we really have so much data from Mars that we can work with every single day with all the rovers and orbiters, that it's an unlimited supply of new data and pictures for us to look at.
Wow, I love that phrase. Well, the other planets are great. The other planets. Yeah, the other planets. Yeah, it's fabulous. All right, let's go across to Trundle Central School. And Carl, you have a question for Jen.
We read that you were involved in helping choose a landing site for Curiosity. What did you have to do?
So when I worked on landing site selection, the first thing we did is everyone submitted their favorite landing site all over the planet, and there was over 100 of them. So what we had to do is we had to narrow it down to not just the best geology, but also the safest landing site, because the engineers only want to land a rover in a very flat, safe area that's low in elevation. If you land it on top of a mountain, there's not enough time to slow down through the atmosphere. So you have to pick a lower elevation. Craters are great for that. But geologists love rocks. And so really smooth areas don't have lots of outcrop and rocks. So we needed to find a landing site that was a smooth area right next to an area with great geology exposed. And the reason Gale Crater was picked is because we have this mountain of sediments, and from orbit we can see the mineralogy of clays and sulfates. So you're having this change from a wet to a dry environment because clays are formed in a very wet environment, whereas sulfate salts are found as an evaporite in a very dry environment. So we knew there was some kind of changing environmental conditions here, which was so tempting, which is why we ended up picking this landing site, that we can go study an area we know was once wet and then became dry. So we're studying what happened and why did that happen.
Actually, we're looking at a picture of Gale Crater right now. So what was and you probably know that picture very well, I'm sure. What are some of the, and we can see the landing site just there to the sort of bottom corner, or just at the bottom edge. What's the...
Right, so...
What was special about that particular, like that exact location, or is that just where you ended up bouncing?
No, so that mountain is 5 kilometers high, and it's all layered sediments. And so while the top part is aeolian sediments, the bottom part of that mountain is these clays and sulfate salts. So the reason that landing site was picked is because we have beautiful exposures of the minerals at the base of the mountain near that landing ellipse. And that landing ellipse is also very safe without any large craters inside of it and fairly smooth for landing. And so we actually landed within about 2 kilometers of the center of the landing ellipse, which is incredible seeing how this rover traveled over 300 million miles.
How big is that ellipse?
That landing ellipse is about 20 kilometers in its long direction.
Okay. Wow.
That's precision.
Yeah, that is. That's fantastic. All right, thank you. So, let me see.
Well, Zane at Casilla High School, you have a question.
Okay, yep.
I know that a Mars day is longer than Earth day, but do you live on Mars time or Earth time?
So a Mars day is 24 hours and 37 minutes. So in the beginning of the mission, when we first landed, we lived on Mars time, which was very difficult because your day shifts 37 minutes later every day. So for example, if you come into work at midnight the first night, you have to come in the next day at 12:37 and so on. So you never get adjusted to a night or a day shift because you're constantly changing, getting later every day you have to come into work. And it was really difficult, especially when you're on for 4 days and you're off for 2. It's really hard to stay on a night shift when you really want to go back onto a day shift so you can see your friends and family. So we did that for 3 months so that we could maximize the amount of science we did with the rover. So if we're living on Mars time, we're always planning what the rover's going to do tomorrow while it's sleeping that night. And by the time the rover wakes up in the morning, we've already planned its entire day for it. So we don't waste any time. Now, we lose some days because we work on Earth time. And so sometimes we don't get the data down before we have to plan tomorrow. So that means we can't do things like driving. We can only do targeted remote sensing around us where we can look at, use our laser, our camera, because we don't have yesterday's data down to know exactly what the rover did.
So how does that affect your personal day?
When we're on Mars time?
Yeah, well, just all the time. I'm just kind of curious if you are thinking off planet all the time. You're thinking about your favourite planet rather than Earth. You're thinking about Mars, so everything you're doing is kind of Mars time. I just wondered, do you think that makes you different in any way?
No, I don't think so. I think a lot about Mars during the day. Excuse me. And I think about all my other favorite things in the evening. So it's a long day for me. Sorry.
And what are some of those favorite things that you're talking about? The other favorite things?
I love to sail. So I grew up sailing my whole life. I love to race sailboats. And I love to cook. And I love American football.
Fair enough. Alrighty, so we've got a little bit of a challenge for you with our Mars lab here. One of the things that students do when they log in, and some of the students that are visiting us today will have done this before, is that we have, just like you guys at JPL have your own Mars yard, we have a Mars yard as well, and students log in and they can drive our robot rovers around that Mars yard to try to search for evidence of life in kind of the same sort of way, I hope, that you're doing with Curiosity. And I know that some of the work that you do as keeper of the plan and with some of the analysis has something to do with the way the real rover, Curiosity, the way its wheels are affected by the kind of terrain you went over. So I thought we might give you a challenge and show you some of our terrain through the eyes of our rover and see what you could sort of comment, what sort of comments come to mind for you. So we're having a bit of a look at that at the moment. Can you see through there at the moment? Can you see our...
There we go.
Yeah, okie dokie. Okay. All right, so we're looking out across the Mars yard through the pan-tilt camera on one of our rovers. Our rover is called Mawson. So what sort of things go through a planetary geologist's mind like yourself at the moment?
Well, straight ahead, I see really flat, kind of slatey-looking rocks. And so those are typically very safe to drive over, unless you happen to see sharp rocks sitting on top of that outcrop. So what we look for when we're driving is we're trying to avoid the really sharp rocks. But it's not always a really sharp rock that'll do damage to your wheel. If a really sharp rock is in sand, as the rover drives over it, it'll press that rock down and it actually will not puncture holes. But if that really sharp rock is embedded into the surface or sitting on top of outcrop, that's when you would have damage to our wheels.
Actually, I think we've got a few pictures. We'll just put a few pictures up for everyone with some of the damage. You sent through some images of Curiosity's damaged wheels. We'll just bring a few of those up. All right, so we're looking at some of those now.
Yeah, so you can see how some of the rocks have punctured through and made holes. So some of those holes are there from the beginning. Those are normal. But the ones above where the arrows are pointed, we're starting to get tears. And the problem is that even if a small rock will create a tear, as you drive over different rocks, it's really opening those tears up. So they start very minor, and then they get more severe as we keep driving. So we're really trying to make a conscious effort to minimize wheel damage right now and try not to drive on very sharp rocks.
How has Curiosity's wheels held up compared to what you expected? Did you expect to have so much damage, or has it been going better than you expected?
So we expected some damage. It's unavoidable when you're driving on a rocky planet. There was about a 20-day or 30-day segment where we were driving over really rough terrain, and we acquired more damage there than we expected. And that's when we really had to stop and find a new route and reassess and do lots of wheel imaging to make sure that our wheels were still okay. And even though you see a lot of damage, they're still totally fine for driving. It's definitely nowhere near their end of life. But we just are making a very conscious effort to not drive through terrains like that 20, 30-day time where it did a lot of damage in a short amount of time.
So that picture you sent us of the smooth terrain, Steve, we've got that one there, the smooth terrain and the rough terrain. We'll just bring that one up. So how typical, like which is the most common kind of one and which is your preference? Well, looking at the rough one that looks, but mind you, I guess you've got to work out a plan.
Definitely the smooth one is a preference.
Yeah.
So I would say the normal terrain is something in between those. And while we wish it was all the smooth terrain, there's definitely rocks on the surface of Mars. But hopefully, generally the big ones can be avoided and we can drive around them. And small rocks are okay. The wheels are meant to drive over rocks. It's just the really sharp embedded rocks. So those rocks in the rough terrain there are embedded in the surface, which means when we drive over them, they're not sliding off to the side. They're not sinking down into the ground. They're going through the wheels, or making dents at least. So really, we try and avoid those types of areas and go to the smooth. The sandy is ideal.
All right. So, and this is because Curiosity is so heavy, isn't it, as well? I mean, 900 kilograms.
Yes.
Yeah, so I guess, and moving, is there a way of, can you go over a bit faster or slower? Is it affected by the pace at which you go over those rocks?
No, the rover drives one speed, and it's very slow. It's about 127 meters per hour, which is very slow. We were actually driving it in the Mars yard at JPL yesterday, and we were driving it over at sand dunes that we had built just to see how it goes over sand dunes.
This is a replica you mean?
Yes.
Yeah.
And so we have it, it's lighter on Earth because there's only about 3/8 gravity on Mars. We have it the equivalent weight on Earth, what it would be on Mars.
Alrighty. Okay. So what's the you have a role in looking at where the rover's been and then thinking about where it's going and trying to, I guess, find a path that minimises damage. Is that right? Can you talk about that a little?
Yeah, so I've been looking at the terrains we've driven over in the past, looking at it from the ground, which are those images you just showed, and looking at it from orbit using high-rise data. So high-rise data at full resolution is 26 centimeters per pixel. So you can resolve the larger rocks, definitely not the small rocks, but from 300 kilometers in the air, you're seeing 26 centimeter objects, like your desk chair, for example. You could see that if it was sitting on Mars. So what I do is I make maps from orbit and from the ground using a color coding of warm to cold colors. So the reds and oranges are worse terrain and the blues and greens are better terrain. And so what we do is we try and see how well the ground correlation correlates to the orbital analysis, and then how well we can predict what we're going to see in the future. So I've made these orbital maps of where we're driving, and we'll see how well that matches up to what we see on the ground.
So is that what we're seeing now? We're showing a picture of...
These are some high-rise images. That we
so
just
that's
got.
a high-rise image. So that one's not Gale Crater, but that's the exact type of image I would use, and I would zoom in as far as I could possibly go and look for rocks, look for outcrop. That's a beautiful one of the North Pole, actually. There's a great layered stratigraphy in the ice in the North Pole. And sand tends to turn blue in false color.
I was going to say that. They're false coloured. That's not the colour of our favourite red planet, is it?
No. So blue, when you see big blue spots like that, those are big sand dunes.
Okay. Alrighty.
All right. So we're going to go to back to PLC Armadale. Rhea and Phoebe have a question for you.
How long does it take to make a map, and have you ever made a mistake?
Definitely. So a map takes, depending on the scale of it, anywhere from a couple of hours to a couple of months. So this morning I actually made a map for my boss of the area where the rover might be driving in the next few weeks. And so if looking at small areas like that, I can make a map in a couple of hours. But we mapped the entire landing ellipse before landing so that we knew when we landed, we knew what the geology was going to be in that area. So those maps were split up among many people of the team, and those took months to make before landing. And yes, we make mistakes all the time. Like, for example, you land on the ground and you see different geology than what you thought you'd map from orbit. And the reason is that from orbit, you don't get everything at full resolution. So you're seeing things at 26 centimeters a pixel, but you're not seeing the little rocks, the small layers. So you can really refine your maps a lot when you get onto the surface.
Are you getting better at that as time goes on, at making the predictions?
Yeah, absolutely. And we start to know what we're recognizing. You know, you see different types of terrain many times, and you start to realize that's what you're looking at.
Mm. And what about Curiosity itself? Because I know that it does quite a bit of autonomous driving now, driving by itself.
Mm-hmm.
How do you feed that kind of information to it, or can you give it some map options or something like that so that it can pick its own path?
Yeah, so the engineers will program the rover to use AutoNav. And for example, it can set limits. So we were discussing yesterday when we were in the Mars yard, okay, we can set a limit of 20 centimeters, which means that anytime it sees in its meshes a rock or a sand dune bigger than 20 centimeters, it'll either stop. If it finds a safe route around it, it'll go. And if it doesn't, it'll just stop and wait for instructions. So you can set those parameters to 30 centimeters to 5 centimeters, whatever you want, based on the terrain that you can tell you're in. If you're in more questionable terrain, you're probably going to set your limits much more conservative. Whereas if you're in open plains or with lots of sand dunes, you can kind of give it a little more free will to drive as much as it can, knowing that it's safe all around you.
Alrighty. Let's have another one here. We're going to go across to, where are we going? Over to Condobolin. And Angus has a question for Jen. Angus.
If you had a chance, would you go to Mars?
If I had a chance, would I go to Mars? Is that the question?
Yeah, to your favourite planet.
I don't think so.
Oh.
I would go to the moon, but the moon is only 9 days round trip, and Mars would be years and years. And it takes about 8 months to get there and then to get home, and you need to be there long enough to make that journey worthwhile. And that's a long time to be away from Earth. And I think being stuck in a spacecraft for 8 months would be really difficult. So I really hope people go there, but I don't think it would be me.
When do you think that people will be going to Mars?
I think definitely in our lifetimes, but there's still so many things to figure out. Besides just the whole food, water, oxygen, waste, you have to decide if you're going to send all men or all women or a mix. You know, how you're going to keep people in such close quarters, how you're going to deal with the radiation for such long periods of time, how you're going to deal with the muscles, and how, you know, the longest anyone's been at the space station is maybe a year, and their muscles really start to lose density. So when you're gone for years, how are you going to keep your body strong? So there's a lot of things we need to figure out before we go on a trip that long. And I really hope it'll be in our lifetimes. And I think it will. I mean, just look at the progress we've made from the beginning of the space program in the 60s to now. It's really quite amazing. So I think in another 40 years, we can do way more.
So if you were, we've got lots of students watching now, and hands up students who are thinking that maybe science, maybe even space science now, could be a career option or even a possibility. Anybody? Any hands? 1, 2, 3. What about here in the studio?
Yes,
Anybody?
definitely.
Let's put it straight up. That's right.
Yeah.
Excellent. Excellent. So a few. So, and maybe, what about just science then as a career? Maybe. Goodness me. A few more hands. Just fake it for me. Will you? Go on. Go on. Okay, there we go. Straight up. Excellent. Jen, if people were, if young people were thinking about going into science, lots of PLC hands going up now.
Yeah.
If people were thinking, young people were thinking about science as a career, what kind of advice would you give them? And in particular, if they were interested in space as a career, what sorts of things would you say to them?
I think if you want to go into space science, you should definitely find a university that has a program in that. So I happened to go to one that had a great Earth geology program and planetary science program, which really gave me so many opportunities to go work on the Mars rover, for example. And some universities are really well tailored to having planetary programs. But as far as science goes, I think most universities are great for that. And I think, you know, even just doing fun projects in grade school, science fair projects, I always loved those. I thought those were a ton of fun. I've always liked science. So I think just getting interested in different types and seeing what you're interested in, because there's so many different disciplines, not just geology. And I think science and technology is our future. I think we're such a big technological world now that it's a great thing to study.
So trying different things and seeing what you're passionate about and what you fall in love with, I guess.
Yeah.
Yeah.
Absolutely.
When you go to cocktail parties or when you meet people at parties and you say what you do, and you say, you know, I work at NASA and I drive the Curiosity, how do people react to what you do?
They usually say, oh, cool, that's the most interesting job I've heard in a long time.
And what do you say?
I say, yeah, I love it. It's so much fun, and it's my dream job.
Oh, good.
How many people get to drive the Mars rover?
No, that's right. Well,
No, exactly.
although they do, isn't it, what's the name of the guy on Big Bang Theory?
I love that show.
Yeah, I've been dying to ask someone at NASA what they really think. I mean, these guys are... Oh, all these hands are going up at the back. They must know. How do people
It's
at
very
NASA...
much like Caltech.
Really?
It's very nerdy.
So which character... I'm presuming not Penny. So which character are you then?
Maybe more like Bernadette.
Oh, that's right. Can't you stop? Don't stop for a car. Whatever she says. I've seen that one.
Hopefully I'm not quite that annoying, though.
Oh, no, I can't see Bernadette there at all. No, that's right.
No, but I love that show.
It's good. We saw some preview photos that you sent us of Curiosity. Some nice selfies.
Some new selfies. We'll just,
what can you tell us about it?
We just took that selfie about 2 weeks ago, and we've been at a place called the Kimberley now for over a month, and we did our drill sample there, and we happened to take another selfie, and you can see all the dust starting to accumulate on our rover, but because we are not solar powered, we are nuclear powered, the dust accumulation is not a big problem. So this is our latest selfie of us. In the other picture, you can see Mount Sharp in the background, which is our ultimate destination. And here we are along this beautiful layered outcrop where we've been studying the rocks. But we actually just drove away today on our first drive away from the Kimberley, headed towards the mountain.
Yeah, so because we spoke with Vandy Tompkins some weeks ago, or actually a few months ago now, and she was telling us that they had just driven through Dingo Gap. We're very excited here in Australia because everywhere Curiosity is going at the moment is Australian. So Dingo Gap, and that you were headed towards the Kimberley, and I remember us saying, we wish you luck in the Kimberley. Yeah, remember that?
Yep.
And you're saying today you are leaving the Kimberley.
Yes, we just started our drive away, and we studied lots of beautiful sandstones, and we see that we're still doing our mineralogic analysis. I think tomorrow night is our big Chemin analysis, which is one of our chemistry instruments. We do a 7.5 hour integration overnight to look at, really high detailed chemistry analysis of the rocks. But we noticed they're definitely different than what we've seen before. So I'm sure you'll see science results in the next week coming out from the Kimberley.
Excellent. We'll keep our eyes peeled for those.
Yeah. So how far is it from here? Because we all know the ultimate goal is Mount Sharp. But and you're saying we're on your way to this is kind of the gateway to Mount Sharp. But so how far away is that at 127 metres an hour?
Let's see.
And you're only driving the Martian day, don't you, as well?
Right. So I can't remember the exact distance. I want to say it's about 5 kilometers to the entry point, but I could be off plus or minus a kilometer in there. I can't remember the exact distance. But with the amount of driving, hopefully we'll be entering the base of Mount Sharp definitely within the next year. But we'll see. We're trying to do these rapid traverse days where we really focus on driving, and we cut down on science a little bit on the days where we're aligned with Mars time so that we can maximize our driving and get there as soon as possible.
So when you have placed the plan out, do you do you have sleepless nights waiting for, thinking, I wonder what happened overnight and what's it going to be like tomorrow? Do you sort of come into work and is there a thing up, everyone starts looking at you going, Jen?
Definitely in the beginning of the mission, we were really excited and really eager to see what was around us. And we wanted to use all of our instruments so quickly. And we had to be very patient before we could drive and use all of our instruments. Now, not so much sleepless nights. We're definitely excited for what happens, but it's kind of a little more routine now, which I guess it's never really routine driving a rover on Mars, but it definitely is a little more normal every day after a year and a half of being on the surface.
So we have time for one last question. Is there anyone from any of our schools joining us who has a question? One last final question for Jen before we go.
Maybe from PLC, because I know you had some other questions yourselves. Anyone got one now, or just someone else listening to the different things that Jen's been saying today?
Yeah, we have one at PLC there. I'll get you when you're ready.
Oh, can I do? Okay. Oh, this is cool. Do I ask her?
Yeah, ask her.
What's your favourite thing about being a scientist?
My favorite thing about being a scientist, I love that every day I come into work and it's something brand new. We have new images, new mosaics down, new data. It's never boring. It's never the same desk job that you sit at and do the same thing every day. It's exciting every morning when I get to work. I love it.
Well, it does sound fabulous.
I have one more question for
You
her.
have
I
one
have
more
one more question for her. When I first advertised that you were going to be speaking for us, you were called Jen Griffiths. And Jen Griffiths. And now you're Jen Shechet. So I know you got married just recently. I just wondered...
Yes, a few weeks ago.
Yeah. And so did you have to plan your wedding around Martian days, around sols?
My whole life is planned around Martian days. Yes, so we got married, and then we had our big team meeting at Caltech. And now we're leaving next week for Italy for our honeymoon. So everything is kind of planned around work and when it best fits in with the plan and when we're driving and when we're staying somewhere for a while. And so it's kind of hard to even leave for 2 weeks, but I'm going to try and do it next week and see how it goes.
So what sol did you get married on?
Oh, that's a good question. It was about 4 weeks ago.
Isn't this
So
kind of wouldn't this be an important anniversary day?
Actually, the day we got married was a soliday, which is a holiday kind of about once every month or so. We have a soliday where we realign ourselves with Mars time.
A soliday. That is fantastic.
We didn't know that.
No, we didn't know about solidays.
That's really interesting. Well, Jen, thank you so much for joining us. We could talk to you all day, but we have reached our time limit. And so, yeah, thanks for joining us. Can everyone just give a big thanks to Jen with us, please? You can turn your microphones on.
Yeah, turn your microphones on and do a cheer. Thank you very much. And we have a tradition here. We have a tradition here at the Mars Lab that at the end of every one of our video conferences, we all say Mars Lab out. All right, so ready? 1, 2, 3. Mars Lab out. Thank you, Jen.
You're welcome.